read it like England and then like said that if you want to do a tune and then September, so like and then meeting team for a week and just say yeah. Like, I'm already doing a business project anyway, so to try and do this mental
Okay, let's get started. I am a bit sick, so I don't know if my voice is going to survive for the whole hour, but yeah, we're going to see. So today we are going to talk about some potential impact of nanomaterials to the society. And so this is, so far in this part of the course, we talk about mainly, how to characterize nanomaterial, what technique you can use, in particular physical characterization technique, you can use to get useful answer to your specific studies. So, here I show a couple of examples that, like you can get size distribution of graphene, measure the thickness, and so on. You get diffraction, so here you get also some morphology, morphological information, and you can do also elemental mapping. So what we want you really to know from this course, for this part of the course, is how to use this different technique to compare, to understand the concept behind this technique, and how it can be used. So I think on Thursday, Mark Bissett should be teaching on Raman, which is nicely complementary to what we have seen so far. It's different scale, but it's also provide different information. We already mentioned it before when we look at the characterization of graphene, right? You remember? Yeah. Okay. So this lecture, we want to have an idea. We want to look and to have an idea about what could be the disruptive effect of any nanomaterial, any nanotechnology, and what could be the hazard related to this material if they were widely used. So we're going to talk about the health issues and what could be the related cause of concern, what could be the source of exposure, and what impact it could have. And we are, in particular, going to talk about the human health and also the impact to the environment. And obviously, at some point, we are going to talk about toxicity and nanohazard. Okay, so one of the main issues with nanomaterials is that there are many things that we don't know, and you don't exactly know what you don't know. So it's not very great. It's not a good start. And usually people talking about toxicity, they like to talk about engineered nanomaterials as opposed to nanomaterials that are naturally present. And well, now you are very well familiar that nanomaterials are many different characteristics. So here just kind of summary of all the different characteristics you can have. So this gives fairly interesting properties. You will know this. And obviously, so these promising properties, they can also induce hazard. And this is what we don't really know, and this is what is good to be aware of what is going on. Also, one other issue is that it's because it has interesting properties, it has the potential to be widely used and globally spread. And so, because of all the you notice that it applies to many different fields, right? Of standard materials. So then it can be used in a lot, potentially, in many fields. And it also means that the exposure potentially can be very high. So and yeah, the exposure to the human and the environment can be significant. So the main question then is it safe? And so from what you know, do you have any idea if nanomaterials are dangerous, are unsafe? No idea? Or you think you are all fine?
It can be burnt.
It can be burned?
Yeah, if they contain carbons.
But if you burn the nanomaterials, what's the safety rating to this? Is it dangerous for you or not?
Well, it might cause explosion.
Well, I guess it's not the main cause of concern, because this is possibly something you could control, right? If you burn it or not. No, it's more like passive exposure, right? Yes.
With graphene, people aren't sure, but some say if the nanoscale is on the same size as like your proteins and DNA and stuff, it could produce cancer and stuff. But we don't know still.
Yes, we don't know, but
So an example.
I mean, there's a lot of metals that went down to the nanoscale and become toxic. Toxicity levels of them, so it's exposed to it.
yeah, is it any metal or is it?
There's well, it's certain metals.
Yeah, for sure there will be metals to be more dangerous than others, more unsafe. So you mentioned graphene. There are recent studies that show that graphene graphene oxide is fine, but there are caveats to this. Is that what graphene oxide? And we already talked quite a bit about this. That if you have highly purified graphene oxide, for example, you will be it's very likely that it will be safe for the body, providing it is well characterized and it's purified enough. If you have contaminant on your graphene, it's very likely that this contaminant, and if you have metals, and we know that we have contaminant a bit everywhere in this kind of materials, then this could be a major source of toxicity. And this is still very clear because most people doesn't talk about the same material in case of graphene oxide because it's highly diverse. Nanomaterial is possibly easier because it's better established. Any other idea on the safety? Was there some another comment? Okay, so yes, we don't really know, and this looks like it depends, kind of. So yeah, we are going. Yeah, what we are really concerned is if it's toxic for human and for the environment. Okay, so this is a list from of the major public health concern from the World Health Organization. And you can see there's the top one is air pollution, and then you have quite a few chemicals. Yeah, this will be like mainly chemicals. Well, there's also radiation, could be quite dangerous, but this can be kind of controlled usually if we don't do something wrong. But yeah, you are, I guess you are already familiar that things like materials like arsenic, lead, mercury, cadmium, they're all materials very toxic. And these are materials that are used in nanomaterials. So obviously, we should not use this material when we design any nanomaterials. Ideally, yeah. So more recently, this engineer nanomaterial has been identified obviously as an emerging health risk, and we do need to work on knowing better the potential risk to help to manage it. So, do you have any idea? Well, I'm going to show this first. What are the main routes of exposure for the human? So obviously there's ingestion, inhalation, and skin absorption. Ingestion is obviously something that we can control, right? It's something that we are active, so we should be able to control it. Inhalation is something that we are more passive, because we can't always control anything that we breathe, the environment that we live on. And skin absorption is also something that we can control to a certain extent. And what is one important aspect to consider also is what kind of exposure you have. Is it just a one-off exposure, or is it a long-term chronic exposure? And obviously the toxicity related to this will be different. So the kind of intended exposure is when we use foods or cosmetics which have nanomaterials in it, and they have a lot of claims that comes with nanomaterials. Food packaging does also contain some nanomaterials. So this is what we could classify as intended exposure. Unintended exposure, which will be obviously more problematic because we'll have less control on this. Then is exposure from our environment, so from the place we live, or the city we live, and the place where we walk to. And you can see you could possibly with contact with any liquid or fuel additives, surface coating, paints also contain some materials, so you can have some exposure there. Yeah, you have this list where you can recognize that you are exposed to some of this in the everyday life. So I show the example of printing, where it has been, there are some papers demonstrated that 3D printed during the printing process by the emission of a particle of diameter of less than 2.5 micrometer. So this is usually called PM2.5. There is also this kind of classification of particulates that you have. And they also emit volatile organic compounds. And this have been studies. So this is in case in this one is yes, it is a mouse. But they look at the consumer use a mouse model, and then look at the effect on on the trachea, so in where it goes through when it goes through inhalation. And basically, what they say that what they observe is that you've got these nanomaterials in the ink. It's got emitted the printing, and then there are some of these small nanoparticles that go down the lung. And we are going to see another paper later, where it's they can monitor the size of function of the size of the particle. The nanomaterial will get accumulated in different parts of the body. Another source of exposure is obviously the environment, the air, so the air pollution. And this is one of the top one of the list I showed before for the World Health Institution. And this is actually a paper where they look at human brains that have been collected in Manchester, and they observe that there are magnetized particles that end up in the brain. And this is so this has been attributed to air pollution and road traffic. So it's something that actually happen everywhere. So they also look at materials that have been collected from the air in other parts of the world, and they observe some kind of nanomaterials. So it's not that Manchester is particularly bad, is the case more or less everywhere. So from the air, we have basically what this paper says, that from the air pollution, we've got magnetite that end up in the brain, and magnetite is apparently the source of concern here is that it could damage some part of the brain, and the fact it was magnetite was very important, because we have different kind of iron oxide, and magnetite was creating this what is called reactive oxide species, and these guys are quite toxic for the body. So if it would have been different kind of iron oxide, it would not have been as problematic. And here also an example of TM images and ILS data where they looked, as they could identify that it is magnetite and it's not something else. So the other structure of iron oxide typically will be goethite or hematite. And they could locate based in different locations of the brain. So, yes, carbon nanotube is something that is you possibly don't expect that if you don't produce it, you will be exposed to it. But again, there are studies that have shown that it has been formed in the airways of Parisian children. So there were children that got asthma, and they need to there are treatments that where they clean the lung, and when they do this treatment, they collect some fluid for the lung. And what they did in this paper is they look at this fluid, and they notice that there was carbon nanoparticles, kind of agglomerates, and there was also nanotubes. And yes, and this was attributed to air pollution, so car fuel and tire particulate that generate this carbon nanotube or a carbon nano object. So this is, for example, let's compare. This is a TM image of a vehicle exhaust on the left-hand side, where you've got this kind of nanotubes, and this is material collected from inside of the human lung. So in this specific case, the children with asthma. and again, they could identify different similar kind of feature from vehicle exhaust to the lung. And these nanotubes are known to be not great, not very safe, and they are actually fairly toxic. So another kind of exposure which is on the skin, and if you use a cream, so usually you can have titanium dioxide nanoparticles in cream because it makes it transparent, and so you don't end up with your white cream. But it's not, as I'm going to show, it's not great for the body. Tattoo is also not very great, so you have all these pigments that can also interact with the body. And the way it works is basically it's interact with it's go through the skin and it's interact with the lymph node, so lymphatic system, and this can react with these guys. So again, they use some fairly sophisticated calibration technique where to monitor what is going on when, so in this case of the tattoo, how it goes through the barrier of the skin, and how it's going, what is the mechanism that the transport mechanism from the skin to the lymphatic system. Nanotitanium. So what it's a food additive. So I don't know if you heard before about E171. So it's to change the color of the food, and this is used quite widely in many different kind of foods. And there are also some concern about the safety of this specific nanomaterials. And basically, there are some studies that shows that it provoke oxidative stress, oxidation of DNA. Well, I will not be able to comment much about this, but this is to illustrate that we are already exposure if we do nothing. We are already exposed to either the environment or even the food, and apparently this was possibly a few years ago. This is fairly recent that France wanted to ban this additive as it is found in many foods before. So it's definitely worth looking at all these the safety related to all these nanomaterials, and possibly put policy in place or change regulation so that we can mitigate it. So is it clear so far?
Could you upload it as a PowerPoint? Because of the PDF, it's not.
It's levels off each other.
Yeah. So
that's what I've got.
Yeah. Okay. I'm going to change it here. Okay. Sorry. Yeah. Usually I don't put so much stuff on top of the area. Okay. So I think David already mentioned that there's lots of nanomaterials can be found naturally, right? And so I guess these ones we are already aware about the safety. We have quite a lot of experience with materials, and as you know, you know that you have seen now that nanomaterial can be used in in any in computing, so to make devices and the phone and so on, some implants and some cream as I just mentioned, and even some sportswear. So there are quite a few emerging nanomaterials, and that are developed in research labs. There are also there's a huge variety of characteristics. So it means that all the effects will be fairly difficult to characterize and so on. So one of the mechanisms that there are quite a few mechanisms that where nanomaterial can affect the body, and different kind of interaction and how the nanomaterial interact with specific parts of the body. And this is usually something that's very difficult to study, to understand exactly what's the mechanism. But is a key to be able to design better nanomaterials that will not be unsafe, which will be safe and will not be toxic. So most of the time, the organs that's concerned will be the lungs, the brain, liver, the spleen, the heart, and the kidney. And this, you can relate at least the two routes we've seen. If you go through inhalation, it will go to the lung, the brain. If ingestion is go to through the liver, spleen, and kidney. Okay. Most of the time, it's interact with the humid cell of this organ. And yes, if we look at more in more detail now in this specific case of inhalation, where basically the largest nanoparticle will get blocked in the nose and in the pharynx. So it will be mainly all the nanoparticles that are larger than 2.5 micron will be blocked in there. Then, so this PM 2.5 that I mentioned before, then they will go to the trachea and to the alveoli of your lungs. And so you can see that there is like the nanoparticle, depending on their size, they will get filtered and they will accumulate to different parts of the body. And this is, for example, what kind some mechanism with the with how it interacts in the alveolus, and this is where the immune system will try to control these nanomaterials. Okay, so there's also only from air pollution, and we've seen that air pollution is, well, it's obvious, but is quite a big deal. We can have all this this toxicity effect, and it can affect all these organs basically. And there are some this route for toxicity. Most of them are fairly well known. They are not completely new, so they are not. They have been studied in the past, and nanomaterials just make it a bit more complex because of the diversity of the nanomaterials, and also it can take a different route at the same time. So it can affect all these various systems. Yeah. Okay. So let's have let's consider now the effect on the environment. And basically, there are two main problems with well, the two main mechanisms where with the environment is how it's accumulated in different parts of the environment, and this is not the slide. Okay, no, this is what I wanted to show. Okay. So the important thing to consider here is how it accumulates, in which form, and how it gets taken by the environment. What is the fate over time, and you know, if it is going to impact the plants, the different organisms in the ecosystem. And usually there's this system which is considered that kind of model the different process of the environment, different stage of biodegradation. Okay, so what kind of source of contamination you can, or contamination or pollution you know from the environment? So I show one example here from waste, from industrial waste. So this is fairly obvious that if we we have industrial emission, we have also solid waste that somehow we need to go somewhere. You also have the all the household waste, so from the population, and which will be all the food, all the goods that you use, and obviously all of this to a certain extent will contain nanomaterials. So. And what we need to consider, obviously, is that you've got some food packaging which contain nanomaterials, and then your food packaging will go somewhere, and then it will at some point will degrade. And what was going to happen to this nanomaterials? So, during this degradation process, there will be the normal cycle of that when you have things emitted in the atmosphere, then it's get deposited somewhere else. It's going in the water system, can go into the soil and go back. So all these pathways are quite relevant. This is the slide I was looking for. Yes. So there are two main things that are quite relevant here. Is bioaccumulation, where it's a chronic exposure of this contamination level, and it says you accumulate with time. So the other one, which is less trivial, is biomodification. Is when contaminants go up the when a small fish hit the plankton, so the plankton got a bit of contaminants, and then the fish will got because it hits a lot of this plankton, it gets some higher level of contaminants, and it go up the chain that way basically, and at the top of the chain we have a very high level of exposure to this contaminant. So this is not specific to nanomaterials. This is a general toxicity. Another example with this is with dioxin, and that's the pure dioxin come from plastic that's being burned, for example, and go up the food chain through the vegetable, the cow, and so on, and can go up to down to the baby, typically. And where again, following the idea of biomodification, the dioxin level will be fairly high. So this is, if we have nanomaterials that come from our waste, we are the ones who are going to be exposed quite badly, and not only from from a direct exposure, but it can also be through the environment. Also, the way that we treat waste nowadays is so if we have the waste coming, then you have different steps where you start to separate the solid from the liquid, and then you've got a few other steps where you have bacteria which will clean the water, and some of these nanoparticles or some of these nano objects can have significant antibacterial properties. So obviously, if this could affect these two steps here, where bacteria are required to clean the water. Yes, so this clarifier steps basically. So far, there is quite a bit of experience with like general toxicity. So, what are the main routes? What are the different pathways? There are knowledge that are missing of, between there are gaps between some of this already established knowledge. So in the literature, there have been quite a lot of disagreements on the specific toxicity aspect of nanomaterials. And this, most of the time, this is related to the fact that people doesn't always talk about the exact same thing. So, and then it's very difficult to get a clear conclusion and clear results. So, most of the time, as I already mentioned before, if there is one fairly well-known mechanism of toxicity is, I'm not sure if it's well-known, but one important mechanism is this reactive oxygen species that will attack quite badly anything in the body. So, from what, or maybe you can try to already summarize what we already have seen so far in what could be the main unknowns on this. Is it clear that we've got this? If we have accumulation and also the we don't know how these materials are going to accumulate. So we don't know what will be the effect, and if they will persist over time. The transport and the degradation of this material is also not very well known. And as I mentioned in the introduction, because there are so many different characteristics of these nanomaterials, usually one difficulty is you have a mixture of different effects, and this mixture of effect can have an impact on the toxicity. So basically, one sensible route to manage all these toxicity effects is it beside like trying to understand the toxicity mechanism, is to design materials that are safe, materials that we know are not going to be will not exhibit any particular form of toxicity, and which means that we could replace some we know that, for example, cadmium is very toxic, right? So if we don't use cadmium in our nanoparticles, then this may help. Well, this also requires good understanding on what are the mechanism of toxicity. But creating materials that are safe by design would be a sensible approach to this. And obviously, the aim will be to avoid binding their use, but to enable this innovation for development of new products through safe and safe by design nanomaterials. Clearly, the toxicity need to, what are the mechanism need to be clearly understood. And we still do need quite a lot of research on this topic to be able to make sure that it's not going to create any problem. So, to summarize on this, is there what do you think about nanotoxicity? What have you seen today? Is nanotoxicity something new? Is it toxic? Is it what can you make out of this?
It's just expansion of what we normally call toxicity, as it's understood. On
Yeah.
a larger scale.
So it's not basically nanomaterial follows the same toxicity pathway than any other toxicity which is known. So this is one aspect is like there is no new toxicity. There's no anything new in that sense. But the other thing is like it can go, nanomaterials will accumulate different parts of the body, so we'll potentially be able to reach different parts of the body. We talk about this mixture of effects that can be quite complicated. So yeah, so the nanomaterials use the common pathway. Basically, when you have this reactive oxygen species that's going to damage part of the body, so damage DNA, the membranes, or any cells in general. But it's because of all the diversity of nanomaterials and all the different characteristics, it can interfere with many more pathways. So this is basically a fairly more complicated problem that we had to do we had to deal with before. So the nano specificity related to toxicity is basically the complexity of the mechanism, the different pathways can take and what it can do it. The size is quite important, but it's not only the size, obviously. Okay, so not all engineered nanomaterials are toxic. Some have been demonstrated to be non-toxic. It's a matter of controlling what are these nanomaterials, how they are produced. As basically a bit like everything is if mostly the hazard is mainly at high dose, so we are already exposed all the time through air pollution to a lot of nanomaterials. And yes, so not all are toxic, and they're all different. Even if you take the same materials, it can be sometimes can be toxic a lot, right? So we clearly mentioned this. And the idea, really, the way to go is to make it safer by design. And sometimes, and there are quite a lot of research work where usually, you want to make, that you have a nanomaterial to work well, and sometimes you just want to replace some elements of the nanomaterial because the idea is very expensive or is very toxic. So for a material to be adopted widely, widely spread, it does need to be safe, and sometimes maybe just a matter of focusing some, changing the design of the material. So still quite a lot of unknowns, and this, we talked before about nanomaterials that are, if they are not properly characterized, then even the property can change quite a lot, right? So it's the same with toxicity, obviously. So on the safety aspect, there are still quite a bit of much more academic research needed. Okay, so I put, in case you are very interested, I put some further reading, and I'm going to finish with thanking Cyril Bussy, who got some of this material for this slide. He's a lecturer in nanosafety, so you have people working only on this. And I'm sorry, I was not very fit, so it may have been a bit boring, like my speaking was a bit annoying. Okay. Tomorrow we are going to do a real presentation. So we are going to go through some of the content that we have done this part of the lecture. And so if you have questions, try to prepare questions. The green one.
Ja, send me some time.
Yeah, which is definitely no.
Yeah, which is
Well, I mean,
If anything, I would say. Yeah, I think and also this is graphite.
no, exfoliation steps and then you reduce it. I know, I got very well, I look at the material you're more anxious about, you've got exfoliated graphite oxide. Yeah, because graphite oxide is a few plates, I think, here. And basically it's the same as today, you lead it I think. And then I'm confused with number 13. I said citric acid, go on to something you said. Yeah. Ascorbic acid, that's J5. I'm stuck on question 1.
I've done most of the question. I think I've done most of the question. But if they don't, yeah, I can show you what I've done.
Well, I mean, I've also got that anti-metallurgy one, so I don't really want to spend too much. Oh, I've been trying to read that paper, the English doesn't make sense.
Well, Andy said if you find the paper.
Come on, Darryl. Yeah, that's all well and good, except for the fact that at the same time, I'm still
Molly, just give me a second opinion. No, that's what I was just getting I can do an evaluation on there.
Yeah, for me it would be. It's really good. Yeah, but sometimes in my opinion, I don't know, maybe I understand. Yeah, but he's thanks. Yeah. Cheers, Eric. Hope you get better soon.
Was it the same topic?
It was more by medical devices and that sort of thing.
Yeah. Or did you do your project? Okay. I did know that one. Yeah, sorry.
I can show you I've done most of it. Question 1 is, I think I've got most of the stuff down.
No, it was sabbatical last year, so I just feel like, yeah, that's how I'm evaluating.
No real issues this year.
Last year. That was last year. Yeah, and it was just, we know about that.
Yeah, generally this year, Eric was said so
No, it wasn't.